Tēnā koutou katoa, and welcome to another exciting ALGIM webinar. My name is Mike Manson, Chief Executive of ALGIM, and it gives me great pleasure to introduce today's topic, Building Resilient Communities, Data Monitoring and Risk Tools for Flood and Landslip Management. And it couldn't be more timely than the experiences of the last few days. Now, flood and landslip risk is now one of the most pressing challenges facing councils across Aotearoa. But as hazards evolve, so must the way we understand, monitor, and manage them. This 90-minute session brings together experienced practitioners working at the front line of recovery, engineering, and environmental monitoring to explore how councils are responding to changing risk. The first 45 minutes will provide practical insight into how flood and slope hazards are being understood today, including the role of monitoring networks, catchment modelling, geotechnical assessment, and planning frameworks. Now, the second half of the session opens up to a 45-minute live Q&A with the expert panel. And I really encourage you to share your questions using the Q&A tab, which you'll find at the bottom of your screen. So look for the more and three dots in there, touch that, and you'll find Q&A. By all means, use the chat for conversational, but Q&A great for questions. Right. I think that covers our housekeeping. And without further ado, it gives me great pleasure to introduce you today to the expert speakers, Darren de Klerk, Ben Westgate, Guy Macpherson, and Damian Young. So I'll just tell you a little bit about each of these before we commence. Now, Darren de Klerk is the Director of Infrastructure Delivery at Hastings District Council, where he is leading teams delivery recovery efforts across infrastructure assets following Cyclone Gabriel. His experience spans large-scale silt and debris recovery, bridge rebuilds, transport recovery, catchment and stream management in Havelock North, and the practical application of real-time monitoring, modelling, and engineering advice to prioritise works and reduce risk under high uncertainty. Now, Darren brings a delivery-focused perspective on recovery and how data and monitoring actually influence and support day-to-day decisions, investment trade-offs, and community outcomes during recovery and resilience planning. So a big welcome to Darren. Next joining us will be Ben Westgate, who is a principal engineering geologist with over 20 years experience across the globe. And I know he's worked across Europe, Russia, right through to Australasia. He's worked closely with data and software specialists to create geomechanical data collation workflows that have reduced design analysis time from weeks to days, demonstrating the value in collecting data more efficiently and structured to deliver smarter, semi-automated processes that create more sustainable, resilient, and cost-efficient engineering outcomes. Now, since relocating to Aotearoa 8 years ago, Ben has been with Tonkin Taylor Group, where he continues to focus on practical innovation in geohazard and slope stability assessment. He has driven improvements in field practice and digital logging to lift data quality and now concentrates on optimizing remote data capture through IoT and real-time monitoring systems. Next, we've got Guy Macpherson, who's the sales lead at Adroit, a Spark New Zealand subsidiary specializing in real-time environmental monitoring solutions. Guy has over 20 years experience in the technology sector. He spent the past 8 years helping to grow Adroit business across New Zealand's environmental, worksite, and infrastructure sectors. Guy's industry experience is broad, from aquaculture through to construction, quarrying, councils, and infrastructure resilience, giving him a practical cross-sector view of how real-time data is actually used on the ground. And finally, Damian Young. Damian Young is an environmental leader with more than 28 years experience applying engineering and science to deliver sustainable outcomes for land, water, and communities. He's the founder and managing director of Zealandia Consulting. Damian is also an active contributor to the environmental profession through publications, conference presentations, and leadership roles in professional networks, and has a strong focus on practical solutions that protect and enhance the natural environment. So it's a great pleasure to welcome our expert panels, and I'll now pass over to Darren.
Thank you, Mike, and kia ora, everyone, and thanks for joining today. So as Mike introduced me, I'm Darren de Klerk. I'm the Director of Infrastructure Delivery here at Aotearoa Hastings District Council. And look, firstly, I just want to acknowledge the severe weather events in the Wellington region, other parts of the North Island that are underway at the moment, and the impacts that those are having. I think it's really timely, as Mike alluded to, and it reminds us that our climate is changing. And the work we do to understand, mitigate, and take actions is more important than ever. So on that note, look, I'm here to share with you a little bit about the Havelock North experience, the Karanima Havelock North experience. For those of you that don't know where that is, it's a little village or a town in Hawke's Bay, part of the Hastings District. About 15,000 people reside there. And I'm going to talk a little bit about the experience of Cyclone Gabrielle on that community. I've got some photo or an overview there of the area, and in particular the 5 dams and 5 streams that I'm going to be focused on. So look, going back a little bit, I'm going to talk to you a little bit about what has impacted across the broader ecosystem, the impacts that Cyclone Gabrielle had. And I can't kind of go past that without first talking a little bit about urban encroachment. So I've got some photos here that kind of show the progression from the 1930s through to 2023, where we have our stream environment and our urban densification encroaching on our natural watercourses, which in time have been evolved, have been changed, reshaped, realigned for many reasons. A lot of that is to accommodate some of the urban encroachment that we see today as we see our population growing. In the Havelock North context, we can find a lot of history that dates back to, again, those 1930s, where communities had grappled with flooding, with erosion, with landslide risk. And so we shouldn't be surprised when we see impacts like we did see in Cyclone Gabrielle. In Cyclone Gabrielle, it was a pretty significant event for this catchment. 283 millimetres of rain fell in a 24-hour period. It constituted to about a 250-year event. Those photos that I have there on the right is one of our dams known as the Tika Hika Dam. And that dam ultimately slipped with obviously debris and silt and sediment falling into the dam, resulting in a significant bill, one for that landowner, but also for council. The photo on the bottom left there is an area that was greatly impacted in Havelock North, known as Joel Road, around the Mangaro stream. So again, a different stream and a different catchment, where about 42 properties were flooded out as a result of increased water flow, outsizing, I guess, the capacity of the stream and the pipe network. And again, I just reverting back to this is not a new challenge. It wasn't a new challenge in 2023. And it was something that the community had grappled with for many decades prior. Look, so a little bit around kind of how the system works, which is part of painting that context. And throughout my presentation, I've got a few QR codes which you can scan. It'll take you to some further information. I encourage you to do that and kind of have a look at them in your own time. But just in a really broad sense, we've got 5 dams, 5 streams that all have the same names. So as per my first slide, they result from the Here in the south through to the Kara Te Whenua in the north. And they were installed in the late 70s, early 80s by the catchment board at the time to protect the community and buffer flow from the range above it, known as the Kohinaraka Range, or Te Mara Peak as we all know it. And each of those dams were designed as per this kind of picture on the left, with a throttle culvert that runs underneath the dam wall and a spillway that acts as a control mechanism to relieve or protect the dam from overtopping. Each of these dams obviously have a capacity and were designed largely around the 1 in 100-year event back in the 70s, with we assume at that point no climate change factor included. The Mangaro, which is the greatest affected dam, and I'll show you a few graphs in the next few slides, has a peak of around 370,000 cubic meters of water that it can hold. and in Cyclone Gabrielle, it topped out at about 300,000 cubic meters and enacted its spillway, which created some of the significant effects downstream. So as I alluded to, 283 millimeters of rain fell in a 24-hour period, about 236 in a 12-hour period. So around that 250-year event, and the impact was great. The impact involved the stream overtopping, flooding of over 40 properties around the Mangaro stream, and about a total of about 83 properties across Havelock North being stickered either yellow or red. It resulted in a significant amount of erosion due to the velocity of the water running down the stream channel, and it resulted in some infrastructure failure. So a number of retaining walls as well as a bridge failed along this catchment, impacting again, as I said, a big part of the community. Rain, as I alluded to, was 283 mils. But what's obviously of greatest interest to us is that the dams range in size from holding around 10 meters or 10 meter in height through to 12 meter in height. And in the 50 years since the kind of construction, had never seen more than 5.5 meters worth of rain. So for us, this was the first real test. And at the same time, was a wake-up call for council. And look, I'm going to kind of move now into what we've done over the corresponding kind of 2 or 3 years, and how the role of kind of information and kind of building resilience kind of comes together. But the cyclone for us identified a need for a coordinated strategy, a plan, and a priority work program that obviously helped to address some of the significant impacts of the cyclone. It got a fair bit of media inquiry. It even had an ombudsman review into council's previous management of the system as such. So look, there's a lot of stuff for council to reflect on and look to take forward. And look, as I alluded to in the kind of putting our thoughts out with the Wellington region, this matters now more than ever. We're seeing more and more frequent events. We've got a community with growing expectation and less tolerance for failure. And we're needing to make decisions with imperfect information in the face of significant uncertainty. So all of these kind of things combine, and action ultimately is needed, and being as informed as possible to build that resilience. So for us, it started with kind of how you change or traverse data to decisions to action. So flood risk was realised, as I've kind of walked you through. And we needed to focus on a recovery and delivery perspective. I'm actually going to talk today a little bit less about technology and more about what data and monitoring actually can change for councils when we're dealing with particularly flood risk. I'll share stuff from a delivery perspective and the need to make calls under pressure with incomplete information, and ultimately us being accountable to our communities for those decisions we make. We've obviously built information based around data dashboards and so forth, but ultimately this isn't about those. It's about how do we build confidence, trust, and safety for our community. So we've got to ask ourselves a couple of key questions as we kind of move through this journey. And we did, these are things that we've done. And before we think about kind of systems or sensors or monitoring devices, we actually got to think a little bit about what decisions are we actually trying to support. And for us, kind of it's grounding ourselves in things like when should we close roads or bridges? Where should we send our crews or maintenance people to first? What do we tell the public? What and when? What assets or projects get prioritised? And how do we ultimately kind of make good decisions? And if a monitoring network doesn't influence one of those decisions, it's probably worth asking ourselves why. So again, this photo or this picture on the right is a little bit around the setup of how those dams work. So really integral for us is around communicating and building education. And look, the first question we asked ourselves is getting a better understanding of water movement, water rising, how fast, and the system needed to be able to help us have real-time water level information, link back to alarm system, and help determine some of the thresholds. Whether that's at a bridge, road, community, property level. And obviously that rate of rise is quite often more important than the peak level. And this gives us the ability to get early warning out, to better understand how the system, the catchment is operating. Particularly important in that is the what's actually happening out there. So it's all good and well getting all this information back, but how is it actually playing out in real life? And again, the photo on the bottom right there is a part of the Joel Road network, and that was when the water started to recede in the morning of Cyclone Gabrielle, about 3 hours after the peak. And for us, understanding things like flow velocity, and we've worked with many partners across this program to build that level of information. The traffic light picture on the top there is an understanding of the velocity, so how fast the water flows. And again, that helps us to understand where some of the problems might emerge. And look, hotspots are really important. So I've talked about kind of the data from a water rate rising, but then when you layer that over the top of things like hydraulic modeling, and again, this is just a snapshot of the hydraulic model and under a certain scenario around water, where water is expected to go under certain events. It helps us then pinpoint or identify vulnerable properties, infrastructure at risk, culverts and areas that we need to go and target for maintenance as a result of them being choke points, and ultimately putting our resources in the right place. It also helps us answer the question of how much time do we really have? So we've done a lot of work to understand the different dam responses. So at what point should the alerts and triggers be set at? What do they actually mean to the corresponding stream network downstream? And then how do they play out when we think about things like rainfall intensity? So looking at those events over different time periods, the kind of natural wetness or the saturation in the ground, and ultimately how much time do we have in being able to answer that. So look, it's all good and well pulling all of this together, but ultimately dashboards and this information don't make the decisions. People, the triggers and the systems that we set up ultimately do. We've got to be pretty clear on them and clear on the thresholds and the escalation paths that we set up. So I'm really, really proud of the work that we've done with the Spark Adroit system and our own internal teams, and encourage you to scan that QR code there, which will take you to a dashboard that I've snipped in the bottom right. That's a live 15-minute updates, and that ultimately portrays the level of the dams, has some rainfall forecasting, as well as a number of stream sensors that we've installed, 13 across the catchment. And again, that information is then giving us a much, much better picture. And then we've gone further and we've looked to try and predict how much time we have. So under different scenarios, if those dams were filling and we were still forecasting X amount of rainfall, how much time would we have before the next trigger and the next trigger would work? So I think just wrapping up that, but data becomes useful when it's linked to those key things like clear thresholds and escalation paths. So then taking a step back around how do we make good decisions? So all of this is good, and I focused on the data component and the dashboard component, but then hovering back a little bit and looking at ultimately where does this fit within a kind of broader ecosystem? And for us, that's about being strategic, using the data, communicating with plain language, and acknowledging that we needed to make progress, and that progress needed to be made in with uncertain information, and sometimes it can't be perfect. So progress over perfection. And for our community, that's around being responsive, showing progress, and telling a story. So a lot of these kind of snips that I've put in here are things that exist on our webpage. They kind of show the journey that we've been on since Cyclone Gabrielle in 2023, grounded in ultimately a strategy. And that strategy needed to be linked with our community. They needed to understand the challenge that we have, which I haven't really touched on, is that 92% of the stream network actually runs through private property. So we don't actually own a lot of that network. So we've got a role in maintaining and ensuring that there's a free-flowing conveyance, but we're challenged with property ownership. And again, that's a link back to that urban encroachment that I kind of led into. So for us, it was developing that overarching management strategy that then lent into a part of it, which is around landowner responsibilities, and how can we point landowners to making the right decisions that link into the broader vision and objective that we're aiming to achieve. For us, that was doing this in baby steps. So we developed a strategy that was iterative. So first step was really focusing on a couple of core things, being dealing with the flood risk, taking every step we can to kind of mitigate that as much as possible, managing our streams better, so a big maintenance element, and then education. And for us, education was really important around creating guides, getting out into the community, and building that general awareness. Um, Part of that obviously is taking action. So for us, we developed further data around live, transparent information on dealing with customer requests. So you can see historically a low level of interest in the top graph, through to the massive spike through Cyclone Gabrielle of interest in the streams, whether that's reporting debris, blockages, erosion, flood risk, etc. And that level has reduced slightly since 2023, but there still remains an active and engaged community. And for us, it's dealing with a lot of those old historic bits of information and showing the community that we're tackling them where they exist and the status of them. So this live dashboard exists on our website for anybody to look into and drill into some of the issues across the wider stream and dam catchment. I've touched on community engagement, and for me, any project you work with, regardless of when data is involved, communication and engagement is really important. And there's a couple of key things around that, and that's being consistent, being persistent, so continuing to engage on a regular basis, sticking to your promises, using plain language, being responsive. Again, the CRM is a really important way of dealing with that. Building knowledge and raising an awareness, and ultimately getting community involved, getting them to touch, feel, and be involved in their local catchment. We can't do it on our own, so recognizing that. So one way that we did that was developing a planting plan and having collective action around getting our community involved, and ultimately feeling like they are helping to take care of their backyard. So we've run a number of these community planting days, and again, they allow the community to understand the stream, us to then have drop-in sessions to communicate some of the challenges and some of the ways that we're dealing with those. And look, just to wrap up from me, the reality check, I guess, in this is that you're limited. There's always trade-offs. There's always lessons to take in from a data point of view or from an information gathering. Monitoring comes with an inherent risk of prediction, but false prediction can be risky. But at the same time, hesitation is time and decisiveness matters. So our community is expecting us to make decisions, and they are going to be based on uncertainty and not always perfect. The other risk is that you gather too much information, too much data, and that actually slows the response and your ability to then make a decision in a timely fashion. And practical takeaways for me is you've got to build trust, baby steps, time and time. Again, being consistent, persistent, hovering back up and thinking about the system as a whole and that ecosystem, rather than just jumping into something as a reactive response. And then look at outcomes. So the sensors are a way of dealing or delivering on those outcomes, but they're not the be end and all. And ultimately designed for the people that you're serving. For us in local government, we're here to serve. We are here to deliver for our community. Without our community's infrastructure doesn't have a purpose. It doesn't exist. So ensuring that we ground ourselves in that kind of philosophy. So yeah, look, hey, thank you very much for listening to me. Hopefully that was insightful. Again, I encourage you to scan those QR codes and feel free to reach out. My contact details are there if you'd like to talk about any of this further. I'd also encourage you to put questions in the chat for me or any of the other speakers. But yeah, kia ora, thank you. Over to Ben.
Awesome. Thanks so much. A quick introduction. Mike's just done that earlier. I'm Tonkin Taylor, an engineering environmental consultant based all over New Zealand. Main office in Auckland, but we do have regional offices in Wellington, Hamilton, Napier, and Nelson and Christchurch. I'm going to take a little step back and look at how we monitor and how we understand kind of land management to start with, and then I'll move forwards in terms of how we're using different devices in the field to make more informed decisions on where we need to place devices, why we need to place devices, and the transitional change from a manual system that is currently the kind of go-to within New Zealand into a more automated process, providing data from the field to a workstation via a platform or a portal that everyone can log into in near real time being kind of a 15-minute to a 2-hour lag from what's actually occurring in the field. So if I can just, I think I can click going forwards. Oh, sorry, too many. So there's mainly two. Well, there's two environments really for monitoring locations. We've got a rural agricultural infrastructure, so that's remote. Generally, these are areas that people don't access every day. We've had great advances recently in terms of technology from satellite systems, and now with Spark, with Starlink, that's just going to get even greater and greater. Lots of different devices in this field to monitor. You can use all of them, and it's about how that data interacts with each other. So we're not taking one piece of data, we're actually taking 6 or 7 different pieces of data, and then applying our knowledge and our experience in terms of how each individual component actually makes a holistic understanding of what's going on. The urban environment is kind of the developed area. Great advances recently in terms of excavations to do with generally groundwater. I deal in the ground and how it changes. So you've got groundwater change, you've got settlement, and then you've got the effects of construction. That's a whole new topic that we won't approach today. But in terms of landslides or change, and that's kind of where this proposal or this presentation focuses on, is actually how slopes change and the consequence of change, all the way from vegetation removal. So vegetation is a really powerful medium of actually helping a slope stay stable. Often in the developed world, we remove vegetation, fundamentally change the way that the slope reached its equilibrium, and then we wonder why it falls down when either it gets wet or ground level changes, or we excavate it. So excavation, you change the stress in the ground. That's generally why we have a design for changes. There's a lot of historical road and rail and development networks within New Zealand that have been based on a variety of different codes in the past. I think that some of the challenges that we've got moving forwards is when the climate does change, which we're seeing that now. We're seeing these larger, heavier precipitation rainfall events that super saturate the slopes. So it's relatively shallow, but it's really, really intense rainfall. And when we start to modify slopes, we need to be really careful about how we modify them, and therefore the effects thereafter. So after a period of heavy rain, often we get the rebound in groundwater. So it could have been static for, I don't know, 3 or 4 years. You suddenly get a rainfall event. We saw this significantly with Cyclone Gabrielle in 2023. The groundwater profiles changed up to 30 to 40 meters in some areas in Auckland that we'd already monitored. We never knew that existed before, because we had this manual technique where we'd go out and would dip a borehole, and generally the way that we measure groundwater, and it was sporadic, so we'd do it every 2 months, 3 months, 4 months. But with the automated technology, we'd put a level logger in the hole, and suddenly we had this brilliant profile of actually what Cyclone Gabrielle did to the ground. And then with rainfall events, that sudden saturation of the surface, it does fundamentally change the material properties of that surface, and the surface, the soils, are generally the weaker materials, and they really don't like becoming wet, especially if they're saturated very, very quickly. New Zealand has done some great work in the last kind of decade with a series of slope stability guidance documents. These are through the New Zealand Geotechnical Society. I think there are 7 different units that are either finalised, unit 1 for general advice, has actually been finalised. I think the other 2 to 7 are currently in draft, and they worked through everything from how to calculate the stability of slopes, what's important for different regions. New Zealand's incredibly diverse geologically, so something that applies in the north of North Island probably doesn't apply in the south of South Island. So there is that regional context, and the 2 images on the top right have been actually taken from that document, so they're public source. So these are really why we monitor these rather large slopes. There are a variety of different methodologies. Some are more manual, some are now satellite-based as well. But the main thing is how we actually get the data from the field into an area where more people can make an informed decision at the same time. So we've got real-time data that everyone can see on a daily basis. So we've been doing some work with Adroit recently, and there's a case study that follows in terms of actually understanding the hazard and the consequence of that hazard for large linear infrastructure projects. So in this case, it was a power line. We had 3 power poles that had to span a valley. And Adroit came to TNT and with the challenge of where do we put the next pole that's not in a hazard zone. So we did a really high level geomorphological map in terms of what the hazards were from landsliding in this particular area, where we felt that the ground was most stable, and because this was a critical linear asset, how we would actually go to monitor this location. So it is rural. You're not going to be able to pop up and make sure it's still there after a period of heavy rain, and the environment has got a history of instability. So we proposed a variety of different locations, and those locations were then ground truthed by the team in the field, and we decided that we would instrument the power pole that went in with a tilt meter. This is the dashboard that then flows from that tilt meter, so we can make informed decisions. So there's two directions for that tilt meter. This really does show like minimal movement. It's super interesting from a geotechnical weather perspective. The yellow line is actually the thermal expansion and contraction of the pole between night and day. And that's why it moves a little bit, both the instrument and the pole. We're actually starting to find all these different nuances with the data that we're collecting because we've got data that's live streaming into different platforms. There's other ways that we can monitor slopes. It's just not through tilt. The main one is through groundwater. We're now finding that now that we have real-time data, we can understand the effects of rainfall and the effects that rainfall has in different environments, whether it actually goes into the ground or whether it just flows over the ground, and is more surface flow. So therefore it's more related to surface water flooding opposed to actually deep into the soils that can cause larger scale deformation and landsliding. We're continually evolving the process and the way that we start to monitor, and how that actually comes back into the knowledge base that we do have, and how we're using that to understand the hazard and also the consequence in some of these areas. And on that note, I'll leave it to Guy to actually take us through some of the devices that we've used.
Awesome. Thank you, Ben. Fantastic to be part of this webinar. Thank you for Mike for the introduction. My name's Guy Macpherson. I look after Adroit Sales. Adroit, a little bit of an introduction who we are, because some will know, some won't know. Adroit specializes in environmental monitoring technology. We're acquired by Spark, so there's a great partnership here between Spark, who knows how to scale, has the biggest network within the country, but also Adroit, who's been able to enable our nimbleness around technology within this environmental monitoring space. In terms of where we work, so we provide environmental monitoring across a range of industries and verticals, including work sites, construction. But around floods and slips, what is of interest is weather stations, so from rain gauges through to full weather stations. We do water quality monitoring, so this includes your turbidity monitoring, your pH monitoring, up to E. coli monitoring. The geotechnical monitoring, which obviously Ben covered off a little bit around the tilt meters, the groundwater monitoring, flood detection, which I'll go through a little bit later on around water levels, both contact and non-contact, and image capture, which pairs really nicely through flood monitoring. In terms of what makes a solution successful, so Adroit's strength is that we're an end-to-end solution provider. So rather than having 1,000 sensors, pick one. We've got a team where we're assessing technologies. Technology's always evolving, and so we become your technology house. So we bring best of breed technology into the country. We're looking at sensors, data loggers, how they combine together, looking at their solar, their battery components, but also looking at how they're going to be installed into the environment, how they're going to be maintained, how they're going to be calibrated. So we get these independently tested as well in country, and then we build these SOPs. So we have a nationwide installation team that's able to provide these services, or we deal directly with council or consulting teams and provide the SOPs, but with the umbrella support. All of our solutions operate in real time or near real time. So that means that they're designed to work on the cellular or on the satellite network. That data comes back to the Adroit platform as a device management platform that basically provides as your basic dashboards, alerting, thresholds, iOS, Android apps, all the things you'd expect to see within the platform. But the key being it has a full set of APIs. So this feeds back to your GIS systems, through to your third parties such as Hydrotel, through to your databases, wherever that data needs to go. We provide that servicing and support in the background. Behind these solutions, it's our partnerships that are super important. So while we bring these sensors into the country, we use, for instance, whole laboratories to set up sensors and test them to make sure they are operating the way that the vendor says they're going to work. We work with clients such as PDP around air quality to understand what the sensor needs to be doing and is it doing that, and build the SOPs around those solutions for our clients. We work with Zealandia around water SOPs and around that calibration, that verification of the data to make sure that while we're collecting the data, that data is accurate and can be trustworthy. And obviously working with Tonkin Taylor as Ben went through. So why is real-time monitoring important? And I think obviously it's been covered off a little bit by Darren, but around floods and landslips, we see massive benefits because what it's doing is taking that reactive decision making we're seeing to a proactive stage. And there are 4 key benefits we see within real-time monitoring. So the immediate and relevant alerts. Obviously, if you have water levels coming up, you're able to get timely alerts and you're able to make actions in real time around how you're going to react to that particular event. Better data and insights mean that not only can you react to that particular event, you can actually use that data for better planning, better resourcing, looking at where your network is under threat, where it is being overloaded, and where you need to put in those resources to help make the network perform better. Community engagement is something we're really seeing. The community is very, very engaged into what is happening around New Zealand in terms of floods and landslips for obvious reasons. We've got installations where the community is within the platforms looking at the data, and we've seen real positives from them actually being engaged in that format, whether or not it's through our platform or whether or not it's through, say, a web browser where the data is fed to, and they can actively see what's going on. And flexibility to suit budget and risk. So with real-time monitoring, it can sometimes seem like a big problem. We need to outfit our whole network, but because it's modular, you can start very small. You can look at where your dark spots are, where your problem areas are, and build from there, because having that data starts building the picture on exactly what you need to do to make your network stronger. Council models of engagement. I thought this would be interesting in terms of how we've been engaged from different councils. So on the first instance, we're dealing with some councils. They have a on-the-ground operational team. They understand real-time monitoring. So what they've got us to do is build the solution, the sensor, the data logger, test it, provide that SOP, but we supply that straight through to their teams. They do the installation, the maintenance. They look after it with our umbrella support behind it. The second way we've been engaged is exactly like that, except our teams will go out and do the operation, do the installation and the maintenance. So providing that resource for councils who potentially don't have that in-house capability, or have the capability but just not the resources to do it. The third one is really interesting. This is where we've been engaged by the council to work directly for the community. So for instance, we're working with Healthy Waters. We started with QMU. We set up 3 different devices to give their community pre-warning that events were happening. We had the community emergency network, the Ken group within the platform, and sharing that data through with the rest of the community. It's had such positive from that, that we've actually started to work with more communities now, working with Healthy Waters. The fourth one, I think, is of note as well. This is where we're starting to work with businesses who are funding the solution, but it's within the council network. We had a retirement home based on the North Shore who were looking at doing flood monitoring, but they didn't want to do it on site for obvious reasons. They can see it starting to flood. They wanted that pre-warning. So they engaged with Healthy Waters, who is helping them with where to place it within the network further up, and also with the permissions to install it there. However, they're funding this. And I think we're going to start seeing more of this type of model as we go along, because everyone is so engaged and want to have the positive benefit from this. In terms of the technology, I'm going to run through the technology. I'm not going to go too deep. But I just want to give you an overview of what we're seeing currently out there. So within flood monitoring, it's all around water level. There's 2 main ways that we monitor flood level. So one's with a radar, which is called non-contact. So this is where the sensor sits above the water, shoots down, comes back, and you actually able to read the water in that way. Generally, councils prefer non-contact because it has lower maintenance. We also have pressure sensors. Pressure sensors are when you have the water, and this is contact, is when the sensor sits in the water. Generally used when you can't install a radar, potentially in culverts and so forth. With the radar, we have both battery, we have both solar, we work with different vendors. How we work out which solution is sitting down with you, looking at your different environments. Often it's a range of these types of solutions. And it's very, very environment specific. Looking at that, cameras are quite often now being paired through with a water level sensor. I've got a video after this. It really gives you a fuller picture of what's going on in an environment, but also validates that what you are recording from the sensor is actually happening. Weather data is incredibly important. So whether that's utilizing rain gauges or actually pulling data from NIWA, having that localized weather rain data alongside of your other data points gives it a much fuller understanding of what's actually occurring. Here is the video. This is actually in QMU, and hopefully I can play it. That's interesting. Oh, there we go. Cool. So we actually have a radar sensor on this video, but as you can see over that nighttime period, the water level comes fully up underneath that bridge. This gives such a better picture to the community of what's actually happening. They start learning their waterways as well in terms of, how high it is, and is there going to be an effect further on the network. Around 2 hours later within QEMU, if it goes too high, they are at risk of flooding. Oh, let's move slides. Cool. Slip monitoring. Within slip monitoring, there's three main ways of monitoring. The main one being tilt meters from a real-time monitoring perspective. Basically, it's a sensor that picks up movement in both horizontal planes. With the slightest movement, you're able to pick up there's been land movement. When looking at monitoring a landslide, you do need to monitor multiple points, as Ben alluded to. And this is where we work closely with our consultants or geotechnical experts to understand exactly where we should monitor. It's through monitoring more data points that you start really seeing the full picture of what's happening. So if you can imagine a landslide, tilt meters across it, monitoring the groundwater, so seeing the water level coming up alongside your rain data, you start to really understand what's happening in a particular location. We've even got examples of landslides where they've got pumps installed underneath, where as the groundwater comes up, they're able to pump the water out to keep the water level low enough to lower the risk of there being a landslide. The network connectivity. I mean, first off, with any of your solutions, they need to work, right? So we've got two options, which is either satellite or cellular. If you don't have cellular connectivity, then obviously it needs to be satellite. What's the difference between the two? There's a slight hardware cost difference and a slight monitoring difference as well when you're looking at satellite. So if you are looking at a network, actually there are soft cost savings if you're looking at cellular. However, it depends on your risk profile. So when we're looking at a region like Gisborne, where there is limited cell towers, they're at higher risk that if a cell tower goes down, they'll lose their coverage. And that's what we're seeing in real terms. So Gisborne District Council works with satellite devices. When we're looking at a region like Auckland, multiple cell towers, you've got a much lower risk that all cell towers will go down, and if they did, to be honest, it's probably a much bigger problem. And that's what we're seeing in real times here as well. So we tend to utilize cellular devices with Auckland Council. These are the types of things we also help with. We work out, able to help you with what connectivity is going to be best, and work out whether or not there is connectivity for that particular type of technology. The bigger picture, obviously combining data point. I know that Darren's touched on this a little bit, or not a little bit, a lot, really gives you a fuller understanding of what's happening in your network, understanding different water levels, your rain gauges, but looking at how this happens over time and how this interacts over time is super important. And being able to collect this data and feed this into your third-party platforms or into your GIS is where the magic starts to happen. I've got this graph here, which I think really highlights the power of real-time monitoring. So when we look at this, you can see the red line there is the bank level, and you can see the water level is less than half full. So we have the first weather event, and there's no change. We have the second weather event, and what happens is 6 hours later, that bank is breached. It then goes back down again, but what you'll notice is the line doesn't actually go back down to where it was before the first two water events. So this is the type of data within your network that without real-time monitoring, you're not going to be aware of. You know, when you look at the picture on the right-hand side, when your network is full, it's not in breach, potentially you're unaware of it. And this is where monitoring in real time starts to give you those insights that you get a better picture of your network and what needs to be done within it. Awesome. Thank you for having been part of the webinar. I am going to hand over to Damian.
Thank you, Guy, and kia ora everyone, and good morning still. Well, it's a pleasure to be here to be part of this webinar and to share some of my experiences and to be involved in the conversation. So, pathway to resilience. How can we get ourselves in a more resilient position? Well, it's all about people. This is very key as I learn how to progress the slides properly. I did. So, who is Zealandia? Well, Zealandia obviously is the continent that we live on, which is you can see behind me. So, we're really excited to represent the new continent of Zealandia as Zealandia Consulting, as a group of scientists and engineers and practitioners. We do our best to come together to solve the solutions of the day. And there are so many things to resolve when it comes to having a better future. And this is just a bit of a slice of those things that we try and take on. So it's important to be multifaceted and multi-skilled in this age. And so we find that is the best approach that we can forward to taking. So we've heard about how there's some amazing things that are going on amongst the panel, and that the interactions between technology and people and governance are obviously really important. And a lot of the information that we might never have been otherwise available to us is now near real time. We live in an incredible time where even people on Facebook are posting things faster than we might be able to consume them. We also live in a time when we're having more frequent storms, and those have been occurring even now, as acknowledged in the Wellington region. And that people actually have higher expectations these days of those that deliver solutions to them from government and from local government, but also I think from the consulting community. So, what is resilience? And resilience is a multifaceted approach to solutions. It's the ability to be able to have property level and wider catchment solutions, and to acknowledge the dynamics that occur in our environment, can create flood risk, and to work towards managing them. To acknowledge things like overland flow paths, which has been quite an important part of the new water legislation that has come into being. And to set levels of performance, and to include the industry in the solutions that we need. Maybe we need to redesign fences, for example. They seem to be a big reason why people flooded in the Auckland context. Maybe we need your standard fence to have a little flap gate at the bottom of it. Hey, it's a human experience, and it's kind of scary and a little bit terrifying, particularly when people are involved in these events, but also for those that have to bring it together across council departments. So this is actually my children were terrified here. So I just acknowledge them and their support in this presentation. And, there was an incredible amount of information that was provided by the community during the Auckland floods. Should this video play? And when those floods occurred in 2023, we immediately were involved in working with and supporting Auckland Council in creating a website called flooded.co.nz. So have a look at that. And that was a way of getting all of this information that people were otherwise putting on Twitter and Facebook, and trying to make it a useful, contextualized data set. You can see people are on the bus and they're experiencing this situation in a really real way. And you can see motorway barrier that acts as a motorway barrier also becomes something that we have to manage for flooding. So there's all sorts of things from a human and technical perspective. And of course, so much occurs within our essential life supporting systems, like our bridges and our motorway network. And sometimes things just don't work. And sometimes the risks that are inherently just trying to play this video, sorry. And sometimes, we'll do silly things. If you see the little car that's moving across the screen there, we take risks in these moments. And sometimes people don't adapt to the situation because they're not used to it. As the chat coming through at 80K with something on the trailer. Being able to reflect this information back to community and to ourselves is actually quite important. Otherwise, we don't understand the impacts. So we need to start building systems that not only take into account all the elements that the others have been mentioning. We can create standard platforms to deliver on these systems. Guy just mentioned about the magic comes when you can integrate your IoT of things, the Internet of Things, and how it might be consumed by your council organizations. Of course, we've got real-time data, but sharing it and having it welcomed within the environment of IT within your government department or organization, often that can become one of the biggest issues. This is where the political side of things is really important. Politicians need to understand the simple things that councils require, and this is why multi-stakeholder engagement, it doesn't just involve community, it's professionals, but it's also the technology providers and the politicians. We have to remain community-centered. It's a very important part of this the process of being resilient. So technology is essential. Without it, we're never really going to get anywhere, and it's evolving so quickly. Sometimes it's difficult to actually be able to absorb just how significant those shifts in technology have been. And it's difficult to necessarily articulate those. And having safe conversations around technology, we find, and I find, is really important, particularly for people that are trying to achieve things as council officers. So the people are fundamental, clearly, and getting them involved and having the community involved, like in Kumeu in that example that guy is talking about. It's amazing because straight away you'll find, and when you get out amongst the people, you realize that they're all busy doing things before a storm. And they have their own stories, and their stories are really vital. And they actually have their own part of the solution. And if they just sat there and did nothing, everything would be a lot worse. They don't. So society is part of the system of solution. And resilience is creating shared capability across different sorts of organizations, between emergency management, between fire and emergency, between community resilience, between iwi hapu, an amazing work in certain areas of New Zealand to support post-flood management. The governance arrangements that we have, it is vital, and it can actually be very, very difficult because of the constraints and the way that we go about procuring new software within a council department. These things might be done by the accountants, but actually what they need to be more reflective of is the strategy. And Darren was talking about the strategy of the work that he's doing, and I think that's really important. We have to have a strategy, and it can't just be about monitoring or about planning or about response, but it has to be, what's our integrated strategy to deliver a sustainable, resilient solution? And so we have to have intelligent and user-friendly digital systems, and we need to be able to have a way that we can manage the workflows of the actions that we do, because there are so many actions after these huge events. In the Auckland context, we've been involved in doing overland flow path property assessments for healthy waters, and we've gone about surveying 4,000 different properties with many other consultants who are partners. And the Flood Recovery Office had to assess 5,000 individual submissions. And each one of those assessments requires some kind of feedback to community. So creating the processes and the standards to do so. Institutional memory is really important. We have to remember that we don't lose that institutional memory of those amazing engineers and practitioners that sometimes leave us through virtue of the fact that they're not working with us anymore, but they're still out in the community. So it's always important to bring them, back into the fold. And I think there's a lot of trust that they garner. So we have to make sure that the community is not left cold because we change the people and the personnel that we work with. But that community trust level is vital. They want to see things that work, and I think they want to understand how we do things and what our challenges are. And I think overall, focus on alerts and preparedness is great. And additional guidance at a property level. What should people do? What kind of action should they take? Being able to provide that at a more global kind of level for all New Zealanders, I think would be amazing. There's a culture and capability of resilience that we can prioritise, that we are prioritising, that we can share, but that does involve everyone across all the sectors. And I think there's an investment portfolio that we have to start looking at. It can't just be individual councils that invest these things. I think we have to be able to share these investments, and then these design tools that are people centered around technology should be quite shareable across the New Zealand family. And I think that's where we'll be much more powerful in terms of the way we go forward. So, the pathway to resilience is all about the people, and sure, it's the socio-technological capability. What thought was quite cool. Digital support tools support human judgment and organizational coordination. We have to build community trust, and we have to involve everyone in the team to find ourselves in a better space for a changing world with many challenges. So, to thank the rest of the speakers and all those attended.
All right. Well, thank you so much, Darren, Ben, Damian, and Guy. And now is the opportunity for you to ask questions of our expert panel. So if you pop them into the Q&A, the question and answer session, you'll find that at the bottom of your screen, look for the button called More, click on that, and you'll come up with Q&A. And so let's begin. The first question that's come through. What do the panel think about the interaction between flooding and landslip risks? Are these considered in isolation too much? Should overland flow path data help inform slip risk? And should slip risks be considered in our overland flow path flood risk mapping, for example? If so, how do we better achieve this and consider the risk more holistically? Who would like to answer that question?
And Ben knows about it specifically, but Ben, you go first, and I can answer.
Okay. In short, I think that they should be considered together. Oh, sorry. I think that they should be considered together. Border generally, whether that's overland flow, it does change and it does modify slopes. So depending on slope angle, because that's the other key consideration if we're going to put them both together. If you have low slope angles, then you generally don't have instability. But if your slope angle is increasing 15, 20, 30 degrees, 100% they're twinned together. Damian?
So we've actually been doing a piece of work for Auckland Council on exactly that. And overland flow paths is one of the things I love a lot. And not necessarily being a geotechnical experts, but we've done that, so mapping interactions between overland flow and slope risk. And there should actually be a view in Knowledge Auckland. If it's not published now, then I'll try and send the link. But there certainly was one done for Gabriel, and there's been an Auckland-wide view prepared that includes both slips and overland flow paths, and their management is integral, not only in terms of that risk, but also in terms of erosion and sediment control within our stream networks, because you'll find that actually post-event, you see that this is where the upper bank erosion occurs, is where overland flow paths suddenly become rivers, whereas before they had no obvious power. So I think they're definitely important. And yes.
Great, thank you for that. Our next question is actually directed to Ben from, it's come from Gisborne District Council, Mohammed there. And he's saying, in practice, how do you decide whether a slope actually requires instrumentation like tilt meters or inclination meters? And once you do, how do you define meaningful trigger thresholds given the uncertainty in ground behavior?
Okay, great question. In a technical context, you generally look at what's downslope of an area that is either it's got a history of instability, or in the surrounding area there are historical areas that have moved. And when I say movement, I mean that displacement could be in the region of 300 to 500 mil, because when you get that level of, although that's relatively small in landslide terms, it does show that the ground is actually now changing, and you're starting to change the material properties from a peak strength to a residual strength. And that could be a reduction of, let's say, 50% of its strength. So if you do have a weather event, those are the slopes that are a higher probability then of failure. How to set trigger levels, for me, that just depends on your consequence downslope movement. If you've got a relatively steep slope, and it also relates, into the mechanism. If you think that there is going to be a debris flow, which is a specific type of landslide that has got a long run out from its source to where it finishes, that's a very different mechanism to, let's say, a rockfall, which might only go 10, 20 meters. A debris flow could go 100, 200 meters. So it is very location specific, but it's all to do with the downhill or downslope consequence of what you're trying to monitor. Hopefully that helps. There is some guidance in the units that the New Zealand Geotechnical Society are just about to publish. That'll be a great resource for everyone to understand and get your heads around. And it'll also help the contractors and the consulting environments, because we are going to have to write to those documents.
Thank you for that, Ben. A question for Darren. Was an uplift in data governance and maturity or data analysis capability required at Hastings District Council? For example, was the value of accurate data entry and data management already well established, or was an awareness capability uplift required?
Yeah, that is a good question. And I think someone talked about kind of a whole of organization kind of change when you go through something like this. So look, for us was a significant engagement from the infrastructure assets team with the need or the problem that we'd identified, and then working in with our our IT and our broader GIS team as well to pull it together. So the Adroit Spark system is one tool that we've got. We obviously have our existing SCADA system that we use, GIS, and we've brought them all together in a common platform. They've each kind of governed by their own kind of data requirements. So it's bringing all of that in and working and having that kind of live connection for us. But yeah, look, it's certainly a work in progress. I think the challenge sometimes is which department as such gets priority, or whose voice is the loudest as you're building something like this as well, and just making sure that you kind of don't forget the kind of need or the problem that you're trying to solve and the outcome you're trying to drive. So again, I just pull it back to communication and internal working.
Thanks for that, Darren. The next question probably for Guy. The network costs for a large number of satellite and cellular connected devices could be prohibitive for some councils. Do the costs of devices and ongoing network connectivity have volume discounts, and could other network technologies such as low-ra WAN or narrowband IoT be an option for some use cases?
Good question. I mean, in terms of costs, definitely satellite at present, while not hugely, but over the course of a network can get more costly. We are seeing cellular costs continue to come down, and I think we'll see the same across satellite. In terms of LoRaWAN means that you need to have a gateway that it's talking through to. So there are pros and cons on LoRaWAN. When the power of being able to have an individually connected device means that they're not dependent on anything else. And I think when we're looking at resilience technology, it's really important not to have to depend on anything else, because potentially things are happening in the network that will stop those sort of connections. But definitely that's something that at scale we can also look at the costings. That's part of the power, I guess, of Adroit being Spark. And we can really look at how we can make that work for a client.
All right. There's a common trap where people want technology, sensors, cameras, other shiny toys to communicate or give the impression we're doing something, but they haven't really thought through the maintenance, the running costs, um, the validation, etc. So a question for Guy, or what the purpose or objectives of this gear are, and a question for Darren. Any tips to help others avoid falling into this trap? So maybe Guy, we'll start with you.
That's a good question, right? And to be honest, I see this more across sometimes not the resilience portfolio. So if we're looking at, say, water quality, I think there needs to be a real understanding of why we're monitoring water quality, where we should be monitoring water quality, how that should work. And that's where we have formed these relationships with companies such as Zealandia, where if the council doesn't have this understanding themselves, we'll bring them in to help have a more robust conversation about what they're actually looking for, what they're looking to solve before we just go, cool, let's throw a sensor in. I think when we're looking at resilience, flood, slip monitoring, generally people are starting off in areas that are at risk or they are concerned about. So it does mean that data does have a benefit, although it depends on how they use it. So if you put the monitoring in and you've got it all going, but no one's actually watching it or it's not going to the right people, then that becomes a problem. I'll hand over to Darren here because I think he'll have a good answer around this.
Yeah. Look, and I think just painting the context of for us, this is one tool in amongst a broader toolkit. We've got other things like water level sensors on our manholes and our other assets as well. We've obviously got all of our flow monitoring and everything. So, but I'm talking about is kind of specific or centric to the catchment of Karanima Havelock North and what we've done in that catchment to again give us a much better picture of how it's operating. Before we got to the Spark Adroit, we did a bit of a business case and an options assessment of all the different products out there and what they can give us in the broader context. Again, assessing against the need, or the objective that we were trying to solve, which was kind of a couple of parts. One was obviously think about kind of that water level, understanding the rate of rise, being able to trigger alerts based on return periods, and ultimately give visibility or transparency to us and also to our community. So hence the dashboard that I kind of linked in there. That is taking the Adroit kind of system, which Guy had a number of snapshots a step further, and making a transparent kind of dashboard that any member of the public can access on their phone or on their laptop during an event. So it's about building the community resilience at a property level. And again, for us, what we've seen in post-cyclone environment is that council, the EOC, can't do it all. We need to build that personal resilience, personal accountability, and to make people have the most informed decisions through the information that's available. So for us, that was the objective, and Adroit was a way of kind of meeting that objective.
Thanks for that, Guy and Darren. And next one is a question for Darren again. It's just jumped. How has the progress made at Heratonga Hastings improved engagement interactions with your emergency operations centre to provide responsiveness benefits?
Yeah, that is a great question, and that also was front of mind. So we've got a steering group, I guess, that sits across kind of some of the starter management stuff, which I sit on. I'm also in the EOC, so I've got a controller hat at times and an operations manager hat. So like the Vaianu experience recently, in our EOC, we have the dashboard up on a screen. We use it as one of our tools along with kind of our Met service and other apps that we have up to, again, make informed decisions. We've then taken that stuff a step further, as I kind of alluded to, with kind of trying to forecast for the operations manager or the controller to make informed decisions around how much time do we have. So if we know X amount of rainfall is still coming and the water level is sitting here, either in the dam or the stream, do we know, we've got 6 hours, 4 hours, 8 hours, when do we need to start that evacuation process if we're going to continue to see the rainfall coming? So pre-cyclone, we had no idea, we didn't have the idea of that. We knew what was happening in the dams. We had historic SCADA in there, and it was kind of very rudimentary, but nobody actually understood what the downstream impact was if the dam was putting out that amount of water. So for us, it's building that much broader picture that then informs personal accountability, but also the decision-making within the EOC.
Thank you, Darren. I think our next question will pop to Damian. how are we making use of AI and technology to support the community when the council IT teams are hesitant to work with suppliers/experts?
I can pick up that if you
Oh,
like.
sorry. Thank you.
Damian looks like he wants to. You go first, Damian.
A conversation about that. I mean, it's a challenge for them as well as for us. And so I think it's how do we do it? We have to find a way to have safe, robust conversations around these technical matters that can't allow, we can't do it, let's not talk about it, it's too risky to dominate the room. And we need to be able to call on, I think, industry practitioners who are really good at what they do, to bring them in the room to facilitate those conversations that might otherwise just be had between the incumbent parties within an organization, because the power of the use of AI is just electric, but also it does some weird things as well, and it exposes various risks that need to be managed. So I think it's by having a system, a process of conversation, and that's how I see it working.
And Darren, did you want to add?
Yeah,
Sorry.
I'll just add a little bit to that. And I think if you think about it, any system you introduce, whether that's a kind of a system like this or a kind of project management system, you've got to consider, and I get it from where the IT teams sit, like there's an enterprise architecture that you're operating within. You've got to understand where this fits in the bigger kind of piece. For us at Hastings, we've always traditionally been kind of innovative in thinking about kind of different ideas, and nothing's been off the table. So we're quite lucky in that respect. And we've actually got an AI lead within our IT team that kind of her role is to go and identify opportunities to improve the business. It's one of our key kind of KPIs to look at kind of reducing costs, but also making our teams more efficient and other things. So we've got a kind of a natural culture here to be a little bit innovative in that space. So we haven't had the burden or the hurdles that maybe others have had. You do need to go and do your business case and your homework and your groundwork as such to go and understand that you're making the right decision, and again, the data and decision making and uncertainty and the progress over perfection. I kind of use the 80-20 rule a little bit with some of this. Not everything is you're never going to find the unicorn system. You just got to go in eyes wide open with what you're doing and the reasons and objectives that you're trying to serve. So, and the key thing is bring IT in early. Like, don't go at 90% of the way and then lump it on them. You're going to have a perverse outcome. I can guarantee you that. So bring them in early and try and explain the need and the problem you're trying to solve.
Thank you for that. I think the next one's for you too, Darren. Is the HDC telemetry linked or joint funded with the regional council?
No, so this is a bit of an interesting one. HBRC, who's the regional council in Hawke's Bay, have got their own kind of telemetry system across the network. They cover the larger rivers, the kind of Tukituki and the Tutaikuri, Narororo. This is a smaller system that ultimately the Karanema Havelock streams I've talked about feed into the Karamu. So the Karamu is managed by the regional council, but we manage these urban streams. So there's a historic arrangement in about 2003 that transferred from them to us, and we've kind of looked after it since. We do kind of, if you go on our dashboard, for example, we link back to HBRC. So we use their rain gauges, for example, to help us predict some of our rainfall. We've got some localized kind of smaller rudimentary rain gauges at the dams, but in a broader sense, we kind of work together with them in that space. But no, it's not jointly funded as such. We did reach out to them when we were going through our business case approach to see what they were using. And again, they were using a handful of different kind of types of sensors and again, relevant to the kind of monitoring that they're doing.
Thank you. Does Heratonga Hastings have its own district-specific emergency management group, or is this managed at the regional level? A related question, how are the data and insights from the system you've discussed today shared with the wider region and neighbouring regions that might be impacted downstream by the elevated river flows, etc.?
Yeah, a couple of questions in there, I think. So firstly, we've got a regional group CDM, so it's managed, it actually sits under the regional council. But our philosophy here, and again, a lot of reflection post Cyclone Gabrielle, is around locally led, regionally supported. So again, the view is that for local events, we'll stand up our local emergency management office. We have our own controller, own department, own function SIMS functions, etc. And then we're supported by group as needed. If it's a regional event, group will stand up and take the lead on it. So it just depends on what's happening at the time, but it's building capability in both of those spaces. Data and insights, yeah, look, again, it's publicly available. Regional Council have done a lot of work around creating a flood and a drought hub post-Cyclone Gabriel. So a lot of their river level sensors, and as I said, when I'm looking at it, we're in an EOC, we'll have their data, our data, Met Service, all of that up on the screens, kind of giving us a broader picture. And there's no doubt heaps of AI opportunities around kind of analysing that and giving us more information. When you think about the neighbouring regions, downstream elevated river flows, at a hydraulic modelling level, we're looking at kind of catchment boundaries and the receiving environment. So the karamu that I referred to before, Regional Council, we have their modelling information that's plugged into our modelling information, so we can understand the impacts of a high level in the karamu to the ability to discharge our streams into them and the impacts that might have. So it's kind of those boundary effects as we work through. But yeah, no doubt there's room to be better at that. But yeah, we consider that.
Thank you for that. Despite all the recent flood events, we're still seeing development in the floodplain going ahead.
Mm-hmm.
And this is across New Zealand as a whole. How do we deal with this issue?
I'm not a planner, but I'm involved in this enough through looking at development, engineering, and consents that come in. Look, it's an age-old issue. There's the NPS for National Policy Statement for Natural Hazards has recently come in. But look, there are challenges. So it depends on your district planning rules. So obviously your district plan will have certain provisions around where you can and can't build. We've recently through here gone through a future development strategy approach to try and allocate land to where growth should go. We talk a lot about the measles map. We want to avoid the measles map of kind of dotted little bits of development in the wrong places and actually focus on it, not just from a natural hazard point of view, but also from protecting our productive soils and other things as well, and allowing infrastructure to service growth in the right places. So really, it needs a planning change, and obviously we're going through an RMA reform process at the moment that will hopefully look at picking that up. That said, fast track consenting also throw some spanners in the work, and if an engineer can show that they can mitigate a risk in a floodplain, then for the most part will likely be granted.
That, if I could. And that is, as planners and engineers, we try and do the best thing. However, there are times when there are other forces at work that will influence why a development goes ahead. And it's watched 20 years of development in Auckland. In various instances, it's not been about the veracity of the planning rules or the function of the RMA. It's been the pressure that is unduly placed on council officers by other parties. And developers and others. So I think that we have to have a more robust process, and even an external party that can readily be called upon to support council officers when they've found themselves getting pressured. And that's probably a pretty political thing to deal with, but I think it is the elephant in the room in this situation.
The only other thing I'd add before we move on from there is obviously the insurance sector is responding as well now to a lot of these changes. So we're obviously seeing places, whether it's media euphoria, but like Westport and others that are starting to see some real challenges to ensure, the ability to insure. And I think one of my slides had the national flood, or the start of the national flood maps are starting to identify things like where is likely to be underwater in a 1% event. So having that visibility so that buyers, developers can make more informed decisions in that space. So just raising more and more awareness in this space. Insurance is one, saleability or valuation is another. So again, shining a light on this in particular will hopefully alleviate it, plus the planning tools that we might kind of need to, as Damian alluded to protect officers and safeguard some of this stuff. I think Ben wants to add to that.
I think we're actually starting to see some of the effects of especially the insurance markets out of the big reinsurance markets as well, not just primarily insurance. And we're starting to learn from overseas what they've done, how insurance is perceived, whether we can actually get insurance on some of the properties in New Zealand, especially after the Christchurch earthquake. I think that was 50 billion. That was the largest natural hazard, I think, per capita in the world. Someone told me on Saturday, and then Cyclone Gabriel was about 4 billion as well. New Zealand is a pretty small island, but it's got this really big insurance risk, and I think we need to manage that responsibly, both as engineers and practitioners.
Thanks for that. Next question. Can this monitoring ecosystem support other types of emergencies, such as wind-driven events, earthquakes, wildfires, etc.? Could the network and dashboards accommodate multiple emergency types in a cohesive manner? Who would like to answer that?
I mean, from our point of view, all of our data is designed to go into the same platform. So whatever sensor it is, we all work within fire detection, a range of different types of technology. But ultimately, our platform isn't always the endpoint of that data. So from an Adroit point of view, we house it in ours, and then we can funnel that via APIs. And that's where that can be obviously utilized in other third-party or council platforms. Darren, you might speak to how obviously you're dealing with multiple data sets, aren't you?
Yeah, look, and I think it just depends how you want to house it and how you want to display it. I think, so we obviously worked with our IT team to bring in multiple different data sets other than just the Adroit system, being our own SCADA system and other things. So it's certainly possible. It just depends, I guess, what you're wanting to achieve. Is it internal use? Is it external use, etc.? But yeah, like it's all possible.
Yeah, and I guess the other thing to add to that is sometimes within a particular platform built for a vertical, you can get more functionality. So while it may be great to have a good view over here, sometimes within that actual platform vertical, it's got lots of functionality that from a practical or operational view is more useful depending on where you are in that path or chain in terms of using that data. So you may have operational teams fully using the platform design for a particular sensor, and then further down from a planning point of view, just adding that to your global data points. Damian.
Be lucky enough to be present at a conference in Christchurch, a GIS conference, Esri conference, and in fact Fire and Emergency were present amongst others, and they were actually demonstrating some of their project developments, which are extensive use of GIS, real-time integration between all the different facets of AEM, and also their field deployment of vehicles and response is actually amazing. So I think there's some incredible things going on in that area, and the new GIS technology is simply it's as exciting and mind-boggling as ChatGPT and other things. So there is a lot happening.
We've just got a couple of minutes left, so I was going to pose a question. Technology is always evolving. How do we know we're choosing the right solution?
Great question. I think we don't always know that we're choosing the right solution. What we can do is the best with the information we have, right? So that's where I guess working with someone like Adroit, who's focused on the technology, can help with that. But in terms of what we're also recommending through to our clients, what we recommend today within a year's time is going to change. And so you're always going to do the best you can. And I think Darren touched on that in his talk as well, is sometimes you need to just have an action and start that process. And so, yeah, I think that's what you can do to help make sure you're making those right decisions. Certainly for ourselves, in terms as a technology provider, we've matured in terms of how we look at technology. So that's why we are looking at sensors and getting them tested by third parties, because sometimes the technology vendor says it does one thing and it doesn't quite do it. And so it's about of looking at it, or potentially it's not as robust as what it should be. And that's where I guess also the strength of you working with someone who's putting multiple sensors there in the environment is that they're also having lots of things go wrong. So they're learning quicker what is going wrong to hopefully make it go right for you.
Definitely. And although there are good tools available, are there any comments about barriers to using those tools?
There might be good tools available. But as I mentioned, often the IT department have got responsibilities or levels of performance for them that will mean that those tools can't necessarily be adopted. So that conversation and the methods by which they can adopt those things needs to be carefully managed. But I think it's about having tools available to all of the councils and community across New Zealand. It isn't actually that every individual should be dealing with these issues. So I think we have to nationalize some of the solution sets and then get on to solving the problems. Because it's actually working on the problems and the solutions. And we haven't maybe talked about that so much, because actually coming up with good, robust solutions on the ground and a built outcome is probably far more difficult, and actually is where the outcome lies, is in something happening that's built. So.
No, thank you for that. And I'm afraid we've reached the end of our time for the panel discussion. And I know if you have more questions, they'd be only too willing to answer those. On behalf of local government, I'd like to say a really big thank you to today's presenters. And we've got Darren de Klerk, Ben Westgate, Kai Macpherson, and Damian Young. Thank you so much for giving up your time to share with us your knowledge and experiences. And we really look forward to following your progress. And let's hope not too many big weather events in the next few weeks, because we've certainly had a few shares. So thank you, everyone.
Well, thank you.
Thank you.
Thanks all.
Yes.